Okay, and welcome to our first day of Algebra 1 final exam review. Welcome to all of Miss Thayer's kids as well who are joining us and listening to this video. So hopefully you all either have this packet or you're going to be taking notes on a separate sheet of paper. Today what we're going to be covering is linear equations, inequalities, and literal equations, and lowest common denominator. So the first few things that we want to review here is what the definition of slope is. Remember, you can have a positive slope or a negative slope. And you can have a zero slope. So we usually use the acronym HOI to represent a horizontal line that has a zero slope, and VUX to represent a vertical line that has an undefined slope. And growing up, you probably always heard slope is rise over run. But this probably is the formula that we go to the most often. Now this year we've learned two different types of lines of equations, or equations of lines. The first one is the one you came to me knowing, which is slope-intercept form, y equals mx plus b, where m represents the slope and xy is a point that falls on the line, and b is your y-intercept. But then we learned a new one with the K's and the H's in it, and we learned that there are definitely some benefits to this, and we call it point-slope form. You still need a slope, and that's still represented by the same letter m, but HK is, H would be the x value of a point on the line, and K would be the y value of a point that falls on the line. So if you know a slope and a point, all you have to do is substitute the K, the M, and the H, and that's all you need. So if I knew, actually we're going to do an example in a second, so I guess I'll hold off. Write an equation in slope-intercept form with a slope of -2 whose y-intercept is 5. So you just write -2x plus 5. Write an equation with a slope of 2, but this time passes through a point. So if they're giving me a point HK, that's when I'm going to use the other equation. So y minus 5 is equal to m, so 2, parentheses x, and then minus a -1 is actually going to make it a +1. Write the equation of a line in slope-intercept form who passes through 2 points. So the first thing we need to do is use our slope formula. So x1, y1, x2, y2. And so we have y2 minus y1 over x2, which I know I kind of covered it up. It's a -6 minus x1, which is a 2. All right, so we get a -1/8. And then to put it in, I know it says slope-intercept form, I'm going to ignore that direction, and I'm going to use my point slope because that's the one that makes the most sense to me right now. So y minus k equals m x minus h. And you honestly could have picked either one of the 2 points that they gave you, and you could use point slope form. So since we just did a few of those, I'm going to skip part B and move on to talking about parallel lines and perpendicular lines. And we really don't do too much with perpendicular lines. We really stick with the whole parallel concept, and parallel lines have the same slope. So if I give you an equation of a line and I ask for the equation of a new line that's parallel to the one given, all I'm looking for is the m value, the slope value. So if my slope is 2/3 and my coordinate point is hk, then I can write the equation of this new line that's parallel to the original one very quickly. Now perpendicular have what's called negative reciprocals. So negative reciprocal, let's jump down to number 8 now. It says write the equation of a line perpendicular to this given the point. So instead of keeping the 2/3, perpendicular actually means I'm going to negative reciprocate it. So I'm going to flip it and make it negative. That's what perpendicular means. You're going to do a lot more with that next year. This year you really have to know parallel. All right, there you go. Horizontal and vertical we know as HOI and VUX. So it says write the equation of a horizontal line, so automatically I'm thinking hoi. And if it passes through the point 5, comma 10, it'd be over 1, 2, 3, 4, 5, up 10. And if it's horizontal, it's the up part that I'm worried about. So it should make sense that if I'm going up 10, and that's the y value of that coordinate, that my equation would be y equals 10. Similarly, if I want to write, let's skip to number 11. It says write the equation of a vertical line. So we know vertical means vux, standing for vertical, undefined, and an x equals equation. So if I plot the point -2 up 1, 2, 3, 4, 5, 6, and it's vertical through that point, well, it should make sense that all I need is the x value of that point for it to be a vertical line. If we do number 12, I'll skip 10, but if we do number 12, it says, write an equation of a line parallel to the y-axis. So let's think about that. If it's parallel to the y-axis, this is our y-axis, we must be talking about a vertical line. So if we're talking about a vertical line passing through the point, then all I need is the x value of that point, because I know vertical lines use the x value. All right, the next part, we're going to solve some equations. I'm not going to do every single one. Feel free to do these on your own if you would like. Let's do some of the more complicated ones that maybe you thought, you would get the wrong answer. So I'm going to do B and C, and you feel free to do A and D on your own if you'd like. So the first thing I need to do is use the distributive property here. And even over here, there's a little negative in front of our parentheses, so I'm going to distribute a -1. And I know my pen is a little clunky, so just kind of bear with that. So I'm distributing, so that's going to become a plus n there on the end. Combine whatever like terms you can. So I have -2n, and then the 8 and the +2 are going to move together and become a 10. And combine like terms over here as well. So I have an n plus another n is 2 n's. And now let's get all of our variables on one side of the equation. It doesn't matter which side you bring them to. I'm going to add this 2n over to the other side. And maybe in the same line, I'm going to add the 3 to the other side. So I get, I messed up there, plus, there you go. 13 is equal to 4n, and so to solve for n, I divide by 4. And so maybe if you did this question on your own, you would have thought you did it wrong, but that's the correct answer. So let's try letter C, kind of the same idea. I'm going to distribute. So distribute that -2, so it becomes a -2a, a -6, and then a +15 minus 3a. Same idea, combine whatever like terms you can. So -2a minus 1 and -3a plus 17. This one does turn out to be a nicer answer than the last one did. This time, let's add the 3a to the 2 this time. And if I'm doing that, then in the same line, I can add the 1. So, -2 plus 3 is just 1a, and 17 plus 1 is 18, so that must be my answer. If you don't trust your answer, remember you can always check by typing it in your calculator. That would be no problem. Hopefully you all brought your calculators home. All right, let's do a few of these. Let's do one where we have to practice. Let's do A. Let's do E, and then let's do F. And so what we're going to do is we're going to solve them. Then we're going to graph them on a number line, and then we're going to write our answer in interval notation. So interval notation, remember, we learned this year, is it's got either parentheses or square brackets, and then sometimes we use infinity or negative infinity. So we'll see if we need to end up using either of those symbols on some of these answers. All right, so letter A, distributive property again, is greater than 6 plus 4x. All right, I personally always like my letter on the left. So if I can keep my x's on the left-hand side, I'm going to try and do that. So I'm going to move that over. So -16x, And at the same time, let me subtract my 24 to the other side. So I have negative 16x is greater than negative 18. Now, one of the big things you have to remember about solving inequalities is when you divide by a negative, your inequality, or sometimes I call it your alligator, has to flip the other way. So this is going to become x is less than, and then a negative divided by a negative is actually a positive. So that's going to be my answer in inequality notation. Now I'm not going to do letter B, so I'm just going to kind of use some of that space. Hopefully you're able to write a little bit smaller when you're doing this on your own. All right, so I have a number line. 9/8 goes right in the middle. Because this is a less than, doesn't say anything about it being equal to, it just says it's less than something. I'm going to represent that with an open point. And the way that you would shade for all the numbers that are smaller than it would be to the left. Which means the interval that would match that would be going from negative infinity and then stopping at 9/8 with a parenthesis, because remember, filled in is the square bracket. So if it's not filled in, it's the parenthesis. So feel free to try B and C on your own, either using your shading or whatnot. But I'm going to jump to E, and this is what we call a compound inequality. Notice there's two alligators in the expression, well, the inequality. To solve for x, I can't just add 4 to one side. Whatever I do to one side of the inequality, I have to do actually everywhere. So this would become 16 is less than 2x is less than or equal to 30. And then kind of the same idea, if I divide by 2 here, I have to divide by 2 everywhere. So this would become 8 is less than x is less than or equal to 15. Now again, I'm kind of running out of room, so hopefully you were able to write a little bit smaller than I was. So I'm going to go up over here to draw my number line of what that would look like. So 8 and then 15. Because the 8 next to it, the alligator is not underlined, that's going to be open. And because this inequality is underlined, that means it's filled in, it's equal to 15. And then because the x is between those two symbols, I shade in the middle. So when I write my interval, it would be parentheses 8, comma 15 with a bracket. Now, letter F is slightly different in the fact that it has the word or. So or, I always think outside. So or means outside. So I would solve each of these as two separate equations. And then I just graph them. Oops, let me erase that. Okay, let's see if I can salvage that. All right, is less than 5. So even though it looks like two completely different equations, what I'm going to end up doing is actually graphing them on the same number line. So here's 1, here's 5. 1 is less than or equal to, so filled in and shaded less than it. And this is x is greater than, but not equal to 5. So these ones shade on the outside. So when you're writing the interval for that, it would be negative infinity to 1 bracket. And then you can either write the word or you can use the union symbol, and then parenthesis 5 to infinity. All right, our next section, we are almost there. Our next section is what we call literal equations. Literal equations is usually just an equation with a bunch of letters, and then you have to isolate whatever letter they're asking you to isolate. So the easiest one would be letter A, and notice in the directions it says solve for either x or y. So letter A has only an x in it, so to get x by itself, I would just have to divide 5 to the other side. That one's pretty straightforward. Something like letter C would be also a very simple, basic example, because if I'm trying to isolate x, then I would just subtract 5r to the opposite side. You're just doing the opposite operation. So let's do one that's going to make us have to think a little bit more. Let's do E, and then I think actually I'm going to modify one of these. I think I'll modify F. All right, so let's do E. To solve for X, I think most of us would probably distribute the 2. So you have 2x plus 2n. So it wants me to get x by itself. Please don't divide by 2 yet, because just in case that they both didn't have a 2, it wouldn't have worked out very nicely. So actually I want to subtract, always try and move whatever is not directly affecting the variable first. So usually adding or subtracting happens first. And that now to get x by itself, I would divide by 2 and divide by 2. And so now I can get x all by itself and isolated. So usually adding and subtracting happens first, and then multiplying or dividing to isolate the variable last. I want to do 1 and modify how it would be solved, but maybe I'll just write it in. So A, B, C, D, E, F, G, H. All right, I'm writing one in here. Let's do, I want to solve for x on this one. So let's do A is equal to hx squared. And I want to get x by itself. So I don't see anything being added or subtracted, so I think my first move would then be division. So I have A divided by h is equal to x squared. And we just finished maybe a few units ago how to solve things that are raised to the second power. And the opposite of squaring something is square rooting something. And so to get x by itself, we would actually square root both sides. That would be our last step. So I just wanted to bring that one up. All right, last piece here is solving fractional equations. We call this, I always get the lowest common denominator when I'm doing these. If you have a single fraction equal to a single fraction, we can cross multiply. But if we look at something like letter B, letter C, and letter D, I do not have a single fraction equal to a single fraction, so I cannot cross multiply. So if we want to practice cross multiplying, I'm okay with that, and then we'll do one where we have to get common denominators. So we have 5 times 3y plus 1 is equal to 4 times 44 minus y. So a common mistake is when kids cross multiply, they lose the equal sign. If there's an equal sign in the problem, it's an equation. So you want to stay consistent and keep the equal sign in there. All right, so now all I did was I distributed on both sides. I can add my 4y to the other side. I can subtract my 5 to the other side at the same time. So I have 19y is equal to 171. And then I would divide by 19 on both sides. I'm kind of out of room here, so I'm going to squeeze it in there. Divide by 19, and there's my final answer. And feel free to check that answer and make sure that one side of your fraction equals the other side of your fraction. But it should work out. So let's jump over to letter D. This will be our last example. So we have a 2, a 3, and then a 10 that technically is floating over a 1. So if I want to think common denominators and want to figure out a number that all 3 of these go into, my LCD, my lowest common denominator, would be 6. So to turn this into, let me change my color real quick. If I want to get common denominators, to turn a 2 into a 6, I multiply it by 3. Whatever I do to the bottom, I do to the top. Turn this into a 6, I multiply it by 2. Whatever I do to the bottom, I do to the top. And to make a 1 a 6, I have to multiply both top and bottom by 6. Once you have common denominators, and if you want to rewrite it, go for it, but I know me and I'm going to run out of space. So once you have common denominators, actually, I probably have space on this one. All right, let's do it. So we have 3t plus 3. All I did was distribute that over 6 plus 4t minus 6 all over 6 is equal to 60 all over 6. They have common denominators. So if all the denominators are miraculously the same now, which they should be in theory, I drop my bases. And so now I can just solve this like a normal equation. combine like terms, so 7t minus 3, add 3 to the other side, divide by 7, and you get 9. All right, well, we got to the end, and I will see you all in 2 days.